.NET platform, you need to contend your application to maintain and manipulate a set of data points of the same time. So this set of data points may come from various sources such as a relational database, a local text file, an XML document, a web service call, or they may even be provided by the user as an input to your application. But at some point in time, or more often than not, you are going to work with a collection of data. So in the early versions of the .NET framework, developers or programmers made use of a set of types to be able to work with a collections of data that were defined under the system.collection namespace. So the earlier versions of the .NET framework defined a set of types under this namespace to be able to work with collections of data. But as the .NET framework evolved, research proved that the set of types that are under this namespace are inefficient in terms of optimizing memory when they work with these set of data points, and therefore they resulted in type safety. So therefore the .NET developers designed or defined a brand new set of data types of data types to be able to work with a collections of data points of the same type, addressing the issues that arise with the use of these system collection data types. Does that make sense? What I'm saying is that when .NET evolved, when the .NET 2.0 version was released, the C# language was equipped to support a new set of types to work with a set of data points. Né? So these types were more efficient than their counterparts types in terms of performance and type safety. You get what I'm saying? So therefore, the new set of types was defined under a brand new namespace, which is called system.collection.generic. And therefore, the types under this namespace were referred to as generics. So when you say a generic type, you have to know we are talking about one of the type which is found under this namespace. We're going to look now what are those types. But what is more important is to show you the reason the types that are defined within this brand new namespace are favored over their counterparts that were used in the early versions of the .NET framework. Does that make sense? So under this systems.collection namespace, we have types such as array list. We have types such as bit array. We have types such as hash table. Queue and stack. These may not be the only types under that namespace, but these are the few of them and the most common ones to my own experience. So now, there's a problem with the use of these types. One, performance. There's a performance issue that is related with the use of these types. I'll show you why. And there's also type safety issue that is related with the use of these types. I will also show you that as well. We're not going to do a lot with them. It's just showing you the performance issue related to them and the type safety related to them, and then we move away. The types that you should get yourself accustomed to using are those that are found under the systems.collection generic namespace. The generic types are the ones that you should get yourself used to, because those, they address the issue of performance that is related to these types. They also address the issue of type safety that is related to these types, because with the generic type you basically specify the type of data items that you want to add into those containers. These are containers. Basically, these are containers to be able to take a collection of items into them. Yeah, cool. There are two types of memory in a computer. There are two types of memory in your RAM when we work with data. There's a stack memory, which is basically where we store static data such as integers, date, strings, not strings, string are not static, doubles, basically any type of data that is of the value type is stored on the stack memory. And we've got the heap memory. So the difference between these two, there's quite a number of difference between these two types of memory. But one major difference that I want to mention in this lesson is that it is quite quicker to access data out of the stack memory than it is to access data out of the heap memory. So on the stack memory, we say we store data that is of the value type. So if you look at the type hierarchy in .NET Framework, you will find that the most parent of all the types in C# is an object type. An object type is the parent of all the types in C#. Then from the object type, we've got a type that inherits from it, and it's called value type. Value type. From value type, we've got other types that inherit from it, such as Boolean, true or false data points. We have got integers. When you want to work with integers, integers are value type, meaning they are stored on the stack memory. So when you work with numbers that are integers in C# or in .NET, they will be stored on the stack memory. And then we have got the double, floating. There's quite a number of them. Float. So all these are value type data types. So when you work with a data of these type, your data is going to be stored on stack memory. Does that make sense? And then we've got the reference type. The reference type would be the types will be, when we talk about the reference type, we're talking about classes, including the custom class that you will define. We are talking about delegates. We're talking about interfaces. So these are reference types. So when you create an instance of a class, then you must know that the data is going, the memory is going to be the memory to store the data about that object. It's going to be on the heap memory. When you create a delegate, the memory is going to be allocated on the heap memory. When you make an instance of an interface, memory is going to be allocated on the heap memory. And remember, it is a bit slower to pull data out of the heap memory than it is to pull data out of the stack memory, because the stack memory is managed automatically by the CPU, while the heap memory, you have to manage it yourself. That is, you have to deallocate the memory that you allocate on the heap memory yourself if you are writing an unmanaged code. That is a code that is not going to be hosted by the CLR, which is one of the components of the .NET framework. Cool. So why are we saying this? I want to come to the performance issue that is related to the use of these types, because these types, they treat each and every data item that you add into them as an object. And as I have said and indicated to you, that all the types that are there in C# inherit from this type implicitly or explicitly, including the types that you are going to create yourself. So these types treat each and every data item that you add into them as objects. So that means they look at all the types of data that we have exactly the same. There's no difference to them. So how is that an issue? That is an issue because if you do something like this, let's say you are working on a set of numbers which are integers. You are working on a set of numbers that are integers and you want to make use of the array list. The first thing that you will have to do is to create an object of array list in order to be able to work with this container. There. Let's remove this one. Now we've got an array list. Now we can start adding our integers there. Cool. So let's do that. Let's add array list to the list using the add method, which takes as its parameter the item that you want to add into the container. And we're going to start with 2 or 25. You say int.add 50 int.add 30. So you can add as many as you want. There's one good thing that I want to mention about these ones. The good thing is that unlike a traditional array, where you will have to specify the number of items that you want to add into that array, here you don't specify the number of items. That means they don't have a fixed size. They are flexible. As you add items, the boundaries of the array are expanded. As you add items, the boundary of the array are expanded. That's one good thing about them. But the generic types also are designed that way. Cool. So now here are our items. We have added them. And we want to work with integers. We don't want any type of data within this. We want to add only integers. Does that make sense? Here is the problem with this one that is related to performance issues. We said they treat each and every item that you add into them as an object. So that means as an object. So that means you add these two. Yeah? What is going to happen is that we said we have stack memory, yeah? And then we have the heap memory. So what is going to happen is that memory, when you add this, memory is going to be allocated on the stack memory. Yeah? But then, because this array list looks at everything as an object, what it's going to do, it's going to create a reference on the heap memory where it's going to store a data type of type object. Yeah? And then after it does that, it's going to box this number. It's through a process called boxing. It's going to transfer this number that you are adding from the stack memory to the heap memory. Does that make sense? So through a process called boxing, this array type, it's going to box this item that you are adding, which is an integer, which traditionally it should be on the stack, where it's going to be quicker to pull it out when you want to use it. It's going to box this item to be of type object and then transfer it from the stack memory to the heap memory. Does that make sense? So it's going to do that for all the items that you add. Cool. So now when you want to pull that data, let's say you want to include these, you want to process these integers that you have put there. Remember, they are stored on the heap memory. Once you add them there, you have to know that it's going, though they can be actually stored on the stack memory, they're going to be transferred on the heap memory using boxing. Yeah? So in order to be able to use them then, like to involve them in a mathematical operation somewhere here on your code, what needs to happen is that you need to unbox these data items back to their original type, which is an integer. And then after you unbox them to their original type, you need to transfer them from the heap memory, because you can't like directly access them out of the heap. You need to transfer them from the heap memory to the stack memory. Well, that might be done for you automatically under the hood, but that process, it's going to actually create a performance bottleneck for your application, because it's gonna transfer unbox that value back to its original value and transfer it to the stack memory, and then from the stack memory it can be accessed. Does that make sense? So that boxing and unboxing process actually is the one that causes performance bottleneck on your application. Well, for a set of few integers, that might not be a problem, but when you're working with thousands of integers, then you will start to realize the frustration that comes with the use of these types. Does that make sense? Cool. So that is one issue related to the use of these types. The boxing and unboxing causes performance bottleneck. It's because of the way these types treat the items that you add into them. Basically, they follow the same concept. They treat every item that you add into them as an object, and there will be this boxing and unboxing that has to happen as you work with your items within these containers. So with stack and queues, the difference would be in terms of what item you access and what item you can get. For example, with queue, we queue like in shops to pay, and we queue home affairs. We queue like in every service where we want a service, we queue. ATM, Kopimali, we queue. So in a queue, basically the rule of a queue is that whoever comes first on the queue is the one who gets served first. Now, with stack, on the other hand, I wish things were like a stack. With stack, on the other hand, the last one who comes, it's the one who gets served. That's cool. The last one who comes is the one who gets served. That's how a stack works. You make a stack of plates, you put plates in a stack. The last plate that you put on the stack is the first one that will go out of the stack, and the first one that you put on the stack, it's the last one to be served. That's how a stack works. But the concept in terms of how they treat their data points, the boxing and unboxing process, it's exactly the same, and then we're not going to make an example. Does that make sense? That's one issue, performance issue related to this one. The second issue, it's more related to the first issue, it's that of type safety. Because you box things into objects, so when you want to make use of them, you need to unbox them to their original type. And if you fail to box them to their original type, you are going to run into a problem. For example, we said if you want to include or involve the items that you add into these containers in a mathematical operation, and you don't box them to the correct type, obviously there would be an error there. The other problem is that because they treat everything as an object, so that means we are allowed to add stuff like this one. First string. You see the problem there? It's going to allow you to do that. It's going to take this thing and box it, add it to the string. Now you add your custom types. It's going to allow you to do that. It's going to take this thing and box this thing, because this thing can be boxed to an object of that and add it to the heap memory. Now you want to include these things on a mathematical operation. You try to unbox this thing back to an integer because you want to include it in a mathematical operation. It won't be converted to an integer, this thing, no matter how hard you work. Like, you can try your best and not sleep from how many, you will never convert this thing to an integer. It can't. So that means you can't involve it in a mathematical operation. So that's the problem of these non-generic types. We refer to them as non-generic types, while their counterparts, which are the ones that we are going to look at, which are the ones that you are recommended to use, are called generics. They are called generics. So that's the reason why you are recommended to move away from using these types to using their counterpart generic types. So let's look what are these generic types and maybe make an example in terms of how they work. Yes. Now we are looking at the generic types, and we said these generic types are defined under a brand new namespace, and that namespace is system.collection.generic. So you're going to have to import that namespace into your code in order to make use of these types. And those types include types such as enumerable, T, dictionary, T, and list, T. So there's a list of these types, but these are few of them. Where T is basically the type of the data items that you want to add into this container. For example, if you want to add a list of integers, then you're going to specify int there. If you want to add a list of strings, specify strings there. If you want to add a list of doubles, you're going to add double there. So when you use these generic types, you have to specify the type. So therefore, memory is going to be allocated on the stack memory, where it's a bit quicker to do what? To pull data items out of. Does that make sense? Cool. And also the type safety issue has been addressed, because now this container knows that, okay, I only contain integers. So if you try to add anything that is not an integer, that cannot be converted to an integer, then this container won't allow you to do that. Unlike these, they are a non-generic counterpart that allow you to just add everything that you add there. Does that make sense? So let's look at an example. Let's pick this one, list. We want to work with the list of integers. This is how we do that. We use the angle brackets to specify the type of items that we want to add, and then we say int is equals to new list int. Now you can start adding things using exactly the same methods actually. Dot add 25 int dot add 50 int dot add 35, so and so on and so on. If you try to add anything that is on integer, because here you have told it to only accept integer, if you try to add it anything that is not an integer, like so, this generic type is going to tell you that, you know what, you must be smoking your open now. What are you doing? Ne? What are you doing? What are you doing? That thing cannot be an integer. And when you said I must only accept integers. Get what I'm saying? So that's the type safety. So there you only add the items that are the type that you have specified in the container. Does that make sense? So performance issues have been addressed because memory is going to be allocated on the stack. So it's going to be quicker to pull stuff out of the memory, out of this container. And again, the type safety issue has been also addressed because the container now knows that I work with the data items of this type only. So I won't allow anyone to add anything that is not of this type. Cool. Sure.